before I dive into checking capacitors, which is a little tedious because usually you have to remove one end from the circuit to test them accurately, I thought I'd move on to checking resistors. Now, in the old days, one way to make testing capacitors a little bit faster is sometimes they would just cut a lead here, test it, and if it was okay, tack it back together, but that kind of weakens the joints. I'm not a big fan of doing that. Anyways, I started checking resistors in the power tubes because, well, if those are off, they can draw a lot of power and affect the B plus in that weird fashion we've been seeing. So 25L6 that powers the high voltage oscillator coil, those resistors are okay. 25L6 audio output tube, those are okay. So then I moved on to checking some of the power resistors. So it's 4.7K, 6.8K. So one I mentioned earlier that comes off right after the voltage doubler there, and feeds power to the video amp tube. Well, I've got my ohm meter at the junction of the two, so 6.8K. It's reading a little high at about 8.2. Alright, well, 4.7K, however, I can't read it. I'm getting bizarre readings, so either something really whacked out with that resistor, or there's some residual power in some of these capacitors. Well, I hooked up an alligator lead to this point and connected it to ground, or B minus, and I tried testing it again, and it's still giving me crazy readings, so I'm going to cut out one leg of it and see if I can actually measure this thing. Okay, I clipped out one end from the circuit, now I can read it. So there must be some residual power in some of these caps, even though I shorted out that point for a while. Any residual voltage in caps that's feeding into your ohm meter will give you some crazy results. So when in doubt, you got to remove one end from the circuit to really test it. It's a little high, but no smoking gun yet, so I will keep investigating. I started spot checking some of the caps, starting out with the ones that are not this greenish type. So here's a black Sprague, should be good up to 600 volts. It's not. I've got leakage. The flashing light there means that it's leaky. The faster it flashes, the leakier it is. And another one. I've got a green one clipped out over here. See what we get on that. And there's another Sprague down below that. And that is on that 25L6 power tube. So that's definitely something worth looking at. Oh, no leakage on that guy. Should have been careful there. You should not be moving these leads around when you've got this with voltage on it. I should have turned it back to 0. My bad. And let's check the capacitance. It should be 0.05. C2. Yeah, it's about 0.05. So these green ones seem to be alright, but not that guy for sure. And I suspect these guys might be bad too, if that one was. And then we've got these high voltage types down here, and this one looks kind of gooey. These might be oil filled, these Sprague high voltage caps. I'm not sure, so those may need to get replaced too. So for example, that one is the filter cap on the high voltage output. And if that's leaky, yeah, I could definitely see that. Builds up a charge, we see some light in the CRT, and then it shorts out, and then it dies away and builds up and dies. So definitely those are suspect, and I can't test them. I don't have anything capable of putting at 6,000 volts to reliably test those. I can check them on this guy, which puts up to about 500, and see what we get there. But when in doubt, I have modern replacements. I can tack one in there and see if that solves the problem. Well, just for the heck of it, I did clip out that main high voltage filter cap there. Should be good for up to 6,000 volts. And what do you know? It's leaky, which is 500 volts on it. It should be good for more than 10 times that much. So I just may I found, well, if not the problem, certainly a major problem. So I'm going to replace that guy and this other leaky cap I found over here, and I'll reconnect this one to test it okay, and let's try firing this up again. Alright, here we go again. Well, certainly different. Cool. Yeah, well, that helped out considerably. It's very off-center too. The centering control maxed out, so I suspect one of those caps is leaky, or some issue with the resistors in the high voltage divider chain. But can we actually receive anything? And clearly it's still an issue with something collapsing, a vertical collapsing, so I suspect there's another leaky cap somewhere. And no reception, which, well, I mean, it could be lots of things in the RFI front end, but the fact that that detector was disconnected makes me suspicious. There's a detector diode inside that box. It may be bad. It's not really reacting as I change channels. There's no crackle or anything out of the speaker. Alright, well, progress of sorts. I will continue troubleshooting. Oh, and notice the current meter isn't swinging around anymore. So that collapsing, that's another issue. I think it's a vertical oscillator kind of crapping out, but the high voltage seems to be steady now. I took the shield off to get at the detector, and it actually checked okay, so I went back to fooling around with the SUT, and hey, I did get reception, but while doing so, the screen faded out. So I'm hoping it's just a matter of one of the other high voltage caps has gone really leaky and is dragging things down. Seems like I got a bit of a raster when I first power it up. So it would seem my progress was short-lived and I lost high voltage, so I decided to stop messing around and just rebuild this area, including taking out all the old high voltage caps. And while doing so, I noticed that this area had been reworked. These resistors were gone and the values of these had been changed. I think what somebody had been trying to do was take the TS4 late modifications and apply them to the TS4H. So for example, this has a 1 meg, a 1 meg, and then 4 2.2s, whereas this doesn't have any of the 1 megs, and it's got a couple 2.2s and 2.7s. Well, I put it all back like this with the help of the schematic some reference photos from another TS4H and some original Motorola service info. And I unmounted this control to get down in there. That's the high voltage rectifier. And I took a better look at these controls. So at this end, it's a conventional potentiometer, but we've got around about 6,000 volts here. So to prevent the user from getting shocked, they put this plastic extension on the shaft and collar. So it's insulated both from the chassis and the user from touching the control shaft down there. And there's a new filter cap on the high voltage supply. And I've been clipping these out. And I've got some new caps to put in place. I'll have to dig up a few more. And once I tidy that up, I'm going to try powering this setup again and see if I can get a raster back. Okay, I finished some of the work in the high voltage and deflection circuitry. I replaced components on a 25L6 oscillator that drives the primary on the high voltage oscillator coil, and I replaced the resistors and restored it to its original configuration in the high voltage divider string there, and I replaced the caps in the horizontal deflection circuitry, those .001s, and their associated 4.7 meg resistors. Haven't done the vertical yet though. Those caps I tested for leakage with my tester, which only goes up to about 500 volts, nowhere near the 6,000 they're rated at, but I wanted to power it up again to see if the work I had done so far had any impact. And if all goes well, I should get a raster back, and I think you'll notice a little bit of a difference on the CRT face, because this is not the test CRT I had been using earlier. I switched to a different one because that's the one that goes with the set, and taking it in out of the socket put some wear and tear on the pins on the base of the CRT, and these are big bases, and they have 14 pins on them, and a common problem with these CRTs is those pins get loose or even break off. So I switched to a test CRT, which is salvaged from an old oscilloscope, so it's green. It's a 7VP1 rather than the 7JP4. Electrically identical. This just happens to have a green phosphor instead of a white phosphor. And hey, I've got a raster back. And I do have it hooked up to a signal source. So let's see if I can actually manage to tune something in. I got static, which is a good sign. At least something's coming through. A little bit of something intelligible. I got the volume cranked up at 100%. Maybe I can kind of make out an image, sort of. Maybe I'm deluding myself. But it does react when I turn the contrast all the way down, it kind of looks washed out. When I turn all the way up, seems like there is some sort of signal getting through. I'll try adjusting the hold controls on the back. This is the horizontal. It seems like the oscillator is just running way off frequency. As I adjust it, these diagonal lines get to be fewer and fewer, and that's what happens as you get closer and closer, but there are still quite a few, so I know I'm a fair ways off of the lock frequency. And the vertical, hard to say. When the horizontal's at scrambled, it's hard to tell if the vertical's locking or not. But also, regardless, the image is so poor. There should be a really strong signal getting through, and I know all these tubes are good. I might be on the wrong channel. Sounds a little bit better, but not booming like I would expect. Well, it's all the way left, so this should be set for channel 2, and this modulator is not putting out channel 2, so I don't know if these oscillator channel slugs are set right. Might be picking up a sideband though, it's certainly possible. I'm going to try flipping this to a different channel. Ooh. Oh, that's going to be a lot stronger.
Timeless, memorable music is back on the radio. First on your time. 87.7 FM. Great artists. Great songs. Great memories. On 87.7 Me TV FM.
I definitely thought there's some video getting through too. It's just the sync is way off.
I was on heroin. I used crack cocaine.
There we go.
Network.
All
If you have a
right.
problem with drugs or alcohol, you need to call the
Looks like the sound and video alignment are off a bit.
consultation. If you have private insurance, your treatment could be covered with no
It's
out-of-pocket
the best
costs.
sounds about here when the
Call
video
the
is just
Addiction
completely
Network
wiped out.
now.
It's a little unusual in these sets. It's a typical problem with split carrier sets where right after the tuner, the video and sound go off on separate IFs throughout the set. And this is an intercarrier, so these IF stages, it's sound and video in lockstep until you get to the detector, and then it goes into separate audio and video. So generally when you get tuned in for a good picture, you get good sound too. But not so much here.
If you want the lowest prices on your airline ticket.
Ah, but even so, that's awesome. I thought I got an image out of this set. That's about right, everything maxed out. Just turn down the brightness and contrast a bit. Try to increase the picture size a little. It's typical. You change the picture size, you lose lock. Be a little more height. Alright, cool. So I'm going to go through and finish doing a little bit of work on the vertical high voltage stuff, and then move on into trying to figure out why the sound and video are not in step. I finished up work on the high voltage circuitry and remembered to reconnect that 0.5 microfarad cap. So let's see what we get now. In case you were wondering, that's power volume, outer is channel selector, inner is fine tuning, and this is contrast. Alright, well that definitely threw the horizontal hold out of whack. Because last time I turned the set off, I had a nice stable picture. So reconnecting that capacitor definitely had an effect like I kind of figured it would. If you ever worked on these sets before, you may have seen this kind of pattern. So when you're off horizontal frequency, you'll see a bunch of horizontal lines, and you may see multiple horizontal images as you get closer and closer to the right frequency. By right frequency, what I mean is I'm adjusting the frequency of the free running local horizontal oscillator. When it gets close enough in frequency to the received signal, the sync circuitry can take over and lock the two together. But when they're so far off, the sync circuitry just can't compensate for it. So as I get closer and closer, actually I'm getting further and further away. Yep. I'm going to go the other way. So I get 3 images. Or maybe now I got 3 images. Now we gotta walk. So not surprising, I still have the same issue with the sound of video being out of sync. Nothing I would do in the high voltage circuitry is going to have any impact on that. But it does seem like the horizontal hold is a lot more solid now. Even as I tune way off the station, I never lose sync, it seems.
Surprise! Someone think you're not going to see? Why haven't I heard from you?
There was nothing to report.
Don't give me that. This is Margot Lawrence you're talking to.
Alright,
remember?
so
I've seen you operate.
You don't
what
know
next?
Helen.
Well, I am going to go through and check resistors and make sure all the caps that have been replaced with ones that are good. Those big greenish caps. And I might remove some of those, like that 0.5 microfarad cap, even though it seems to be okay, because it's just so huge that it really gets in the way of other components. And a modern one would be much smaller and allow easier access to the surrounding components, better airflow, that kind of thing. I'm kind of torn. I mean, it's an old part, but it seems to be okay. Well, we'll see. We'll see how I go with that one. Oh, something else kind of odd. I noticed a few of these ceramic caps. There's one here. There's one down in there. There's another one. I don't think they're original. And they sure look flimsy. I mean, that is one thin ceramic caps, and there's no voltage rating marked on these, so I think those might have to go. I don't believe they're critical. I think they're just RF bypass caps. I'm not sure why there's one floating up here, though. I gotta check the schematic on that. Let's see. It's audio output tube, pin 1, 2, 3, 4, 5. What do we got for that? Well, that should be, well, it's coupling cap from the audio amp. I'm pretty sure the original was not a little flimsy ceramic cap like that. Maybe that's all the guy had on hand, I don't know. That's going to go. This is what the old ceramic caps look like. I'll have to check out what's up down in here. Why did he replace a couple caps down in there? Ceramic caps very rarely go bad. Especially these tubular types. So if these were originally ceramic caps, it makes me wonder, why did they go bad? Or did maybe he add some extra ones as part of the tinkering that was done with this set? Okay, here's that tube. That's the last IF tube before the detector. And those caps are going to pin 6 and 7. And there's 5,000 microfarad. And there's the other one. Yeah, so they're just bypass caps going to ground. So, I don't know. Pretty sure those aren't the original, but for some reason they got replaced. Well, I did end up replacing that cap. Here's the new one. There's the old one. The original was actually only rated for 200 volts, not 600 like this one, and this was really wedged in there tight, so that's why I ended up replacing it. And made it easier to work on other stuff down in here. And then I moved on through here, replaced some out-of-spec resistors, and left these caps in place because they checked it out all right. So high voltage stuff is done. Down into here, that's the ballast tube socket. And now I'm working over this way. Here's the audio portion. Detector tube 6AL5 is down in here. And here's the cap for the ratio detector. That's going to get replaced. The audio output tube, so check stuff in here, and then I want to move on to this RF amp, local oscillator mixer, 3 IF stages, detector, and then a video amp. That seems to be working pretty well, getting a pretty good picture, but sounds out of whack, so if I don't find anything wrong with any of these components, I'll probably end up having to align it.